Hi, good evening. Welcome back to the Busadi Statistics and Business Academy's ongoing that educational program. Under this program that we've been doing that most of the time that the questions based on the calculus series, but today that in this video that I'm planning to go through a kind of like a different kind of example based on statistical example that is heavily found in mathematical statistics, or especially in that distributional theory that can be heavily utilized in the practical application. Okay, let's go straight to the our discussion, our problem, and see how it works. Okay, how we can solve that one. Okay, this is what they have given. This is being given. The question Q, you can see, yeah. Assume that certain x, okay, given alpha, see, x given alpha is Weibull distributed, Weibull, okay. I'm going to write this one for you to see very clearly, okay. X, okay, x given alpha, I would like to denote this one this way, xw, which is x given alpha, see, if the tilde means distributed, is distributed, that we can use this abbreviation later on down the road, distributed, see, Weibull with shape parameter equals C, shape parameter equals C, and scale parameter equals alpha. See, this is given. See, this means given. X given alpha. See. That means that is, I'll write this way, xw, which is x given alpha, is distributed Weibull with Cn alpha. See, it's a constant. This is varying. It's a random variable. It's a random variable. And also assume that alpha, which is I would like to denote by another x, but with a different letter, is distributed, not given this time. So all the parameters are constant, okay? Gamma with shape parameter theta and scale parameter is 1. This is because of that reason I'm going to call this one xg. Okay. Excuse me. Yeah, theta and 1. Yeah, that is xg, which is alpha is gamma distributed with theta n1. They both are constants. Okay. Okay. The constant, okay, but you can vary that one. Okay, if you want, you can give the different value. See. Then they ask us to show that, okay, show that, I'm going to write here, show that X, this guy, not this guy, X is, I'm going to put B here, XB, for X, because X is distributed with Burr distribution, okay, Burr distributed with shape parameter C and shape parameter theta. That's what we have to show. See. That is, I'm going to a little bit erase this one. That is show that XB or X distributed with Burr C and theta. C and theta. C and theta. See. A little bit less than we can see clearly. See. So how to answer this one? Let's answer this one. This answer. Okay, a fancy answer. We know that XW, which is X given alpha, is Weibull distributed with C and alpha. C and alpha. So, therefore, its probability density function is, I can write the probability density function, F xw, which is f of x given alpha, is nothing but, if you're going to write this one in terms of c and alpha, you can easily write alpha c alpha c x to the power of c minus 1 e to the minus alpha x to the c. See? Alpha c x to the c minus 1 e to the minus alpha x to the c, where x is positive, alpha positive, and c also positive. See, those are the domains. See, in a similar fashion, we also know that xg, which is alpha distributed gamma with theta and 1. See? Therefore, its PDF is f of xg, or f of alpha is nothing but what? Excuse me. 1 over gamma theta 1 to theta, 1 to the power of theta. See, it's like a alpha theta, see, alpha theta, see, or delta something, alpha theta, see, gamma alpha beta to the power of theta. Alpha, this is like x theta minus 1 e to the minus alpha over 1 alpha positive theta positive. Okay, you got the point. Now I have two PDF. I don't need this guy. I need this guy. X, I have to separate x. See, take the x out, not the xw, not the xg. See, we need that one. To do that one, what are you going to do? This is a conditional distribution. See, this is a conditional distribution. This is like a prior distribution. You are looking for the marginal. See, this is conditional. See, this is conditional. Conditional distribution, statistical distribution. I'm going to write distribution in this abbreviation, statistical distribution. This one margin, sorry, this one prior distribution. I'm looking for this guy, which is marginal. To get the marginal, before you come to marginal, you have to go to the joint. Then let's build up the joint distribution of who and who. Just distribution between this guy and that guy, and then you can separate. Not this guy and that guy. X means xb, okay? X Burr and alpha is, how do you get that one? Get that one. Distribution. You're gonna get, I'm looking for xb, sorry, I'm gonna write this one very clearly, okay? It's a joint. X means xb and alpha which means f of xw times f of xg. See, that's the multiplication of those two. That means I'm going to write one more f of x given alpha times f of alpha. Okay. Or I can write this one this way. F of xb given alpha times of alpha. Same thing. See, f of xb given alpha or x given alpha means that guy. Alpha c, see, x. If you want, you can put the x. I think xb. If you want, put the xb here. See, xb. That's okay. xb. Alpha c xb to the power of c minus 1 e to the minus alpha xb to the power of c. See, that one, that should be multiplied by, see, here, 1 over gamma theta, alpha to the power of theta minus 1 e to the minus alpha. See. See, like that. So I'm gonna little bit rearrange this one, okay? So you have alpha, you have a c, you have 1 over gamma theta. I'm gonna get not the alpha terms, the other terms I'm gonna combine because I'm trying to isolate this part only. That means I'm trying to integrate with respect to this guy later, okay? So I get the c, I need xb to the power of c minus 1, I need 1 over gamma theta, okay, I can pull that out. But the rest with the alpha terms, I'm gonna put here, alpha here, see, okay, alpha to the 1 here, this part, alpha to the theta minus 1, okay, that from here, e to the minus alpha times xb to the power of c times e to the minus alpha. Then we can combine, I'm gonna write this one as it is, 1 over gamma theta, c x beta to c minus 1 times alpha to c. This one and this one get cancelled off, alpha to theta. Alpha to theta. Alpha to theta. See, or you can keep them as it is, okay, for a certain reason, but that doesn't matter. I want to see theta plus 1 and minus 1. I keep like that. Here even, I can pull out minus alpha and left over xb to the power of c plus 1. See. See, there's a reason why I didn't take this off, because when we're gonna integrate later on in order to isolate xb or x, okay, x or xb. See, Well, this is the joint. I don't need the joint. I need the marginal distribution of XO, XB. Okay, and see whether it's going to be Burr. Okay, so okay, so therefore, what I need is, this is what I need. The marginal distribution of XO, XB is then what? That's nothing but, okay, that's nothing but, okay, this guy, okay, this guy, this is what we need, nothing but integration of f of xb equals x, so x equals xb comma alpha integrate with respect to alpha. Alpha goes from 0 to infinity. Okay, that means you're going to integrate from 0 to infinity with respect to alpha of that guy. 1 over gamma theta. I'm going to clean this one too. Gamma theta c xb c minus 1 alpha to the power of theta plus 1 minus 1 e to the power of minus alpha x beta c plus 1 d alpha. See, integration has to be done with respect to alpha. Alpha to this one. So for my convenience, I'm going to pull some terms out, okay? I'm going to pull some terms. See? So this is what we need. XB nothing but 1 over gamma theta I can pull out. C I can pull out. X to the B to the power of C minus 1 I can pull out. That's it. The rest coming under that alpha operator. Alpha here theta plus 1 minus 1. I'm going to rearrange this one like this. Minus alpha. Okay. This one like a 1 over. Okay. I'm going to put over 1 over x to the beta c plus 1. I'm going to rearrange like that, see. Divide by. Then you're going to flip. It's going to go to the numerator, see. D alpha. Then what? Then what are you going to do? This looks like a very similar to the gamma distribution. An integral over the whole domain. So we cannot integrate. These are very heavy integrals. When you have heavy integrals, you're going to rearrange. How? In a way that we can set this integral becomes 1. You know the area under the whole gamma distribution is 1. But you have to make sure you put the proper parameters based on what we see there. See? 1 over gamma theta c x beta c minus 1 integral 0 to this one When you have alpha here, theta plus 1 minus 1, this looks like your new scale parameter, sorry, shape parameter. This is a shape parameter. So you should have that gamma alpha. Can you remember we always say the alpha? In gamma setting, we're gonna say this one, then you have the same thing here. To get that cancel off, I'm gonna put that one here. See, look at what I did. I'm rearranging. And by looking at this one, minus alpha over 1 over x to the beta c plus 1, this whole thing, d alpha, this is look like my beta. I'm gonna put the beta here. See? Gamma alpha, alpha to beta to theta. Can you remember? Beta to alpha, beta. Beta goes here, 1 over x b c plus 1 here. The same thing if you put in the denominator, you should put in the numerator. See? You should put in the denominator, you should put in the numerator. See? xb c plus 1 over 1. See? You should put this one. See, I just put this one. This is like my, see, this is like my shape. This is like my scale. See? For gamma, shape parameter for gamma, scale parameter. It says 1 over gamma shape parameter, scale parameter to the power of what? Power of shape parameter, theta plus 1. Okay. This should have a theta plus 1 as well. Okay. Theta plus 1. Theta plus 1. See? The settings say gamma of shape, scale has been raised to the shape. See? Like that. If that's the case, this whole thing is 1. You know that. Whole thing is 1. That's how we're going to integrate. See? This one, alpha to the power of, okay. The leftover would be what? See? See? Leftover would be this gonna, see? I can flip this one and write this way. xb to the c plus 1 minus theta plus 1. See? Minus theta plus 1, no 1 plus theta. And this one I can write, see, the gamma you can take out n plus 1 means n times gamma n. Can you remember? The same way I can say theta, gamma theta. There's another gamma theta here. I wrote this gamma theta plus 1, theta times gamma theta. Okay, can you remember? Those are the properties. This property I utilize. This guy take out and gamma theta. C x beta to the power of c minus 1. See? Then they get cancelled off. Then let's see what you can end up with. Okay. So here you can have, you have C, you have theta, they both you have xb to the power of c minus 1 xb to the power of c minus 1. What else? Then you have 1 plus xt to 1 plus xt c to the power of negative 1 plus theta. 1 plus theta c. Negative 1. That's the left pole. That is nothing but the PDF of Burr distribution with shape parameters theta and c. This is the thing. This is the PDF of Burr distribution with shape parameters theta and c. That is, you can write at the end of the day x or x b doesn't matter. It's distributed with Burr c and theta. C and theta. C and theta. Here you can remember your C positive, theta positive, x equals xb positive. So C theta, I'm sorry, this one, xb to the power of c, okay. See, B stands for Burr, here also B stands for Burr. This is the delta C coming from Weibull distribution, this is coming from gamma. See, with the aid of gamma distribution and Weibull distribution, you can generate a Burr distribution, okay? So you saw that how we did this one is a little bit tricky, some kind of complicated, complex, but doesn't matter. We have all the steps. You can play back and forth this video and then get an idea how the steps been done. And then if you have any question, and you can just email me or just contact me, and then I'm gonna leave that email so we can discuss those things next time. Okay, until then, I'm gonna let you guys go, and you guys have a wonderful day, and then stay safe and be well. Take care. Thank you. Bye-bye.